Hello, this is the Axiom medical pulsatile flow simulator. We're here to demonstrate what it does. This is the simulator itself. This is the attached phantom. The phantom is replaceable with a number of other types, shapes and sizes, and different phantoms to mimic different parts of the body. The phantom is replaceable in a very routine and efficient manner. There's a valve here that doesn't allow any water to leak out of the phantom of the simulator itself, even during functioning of the pump, and the appropriate phantom can be replaced while the pump is still running, allowing you to carry on with your work. We'll start off with a common femoral waveform. I'll show you what the phantom looks like, the standard phantom that comes with the machine. Here we can see a straight tube phantom. You can see that we have both B mode image and the spectral Doppler. I think we need a little bit more gel. Okay, so here we can see the B mode image at the top of the screen. You can even see the speckle pattern of the blood mimicking fluid. You can see some reflection artifact in the lower part of the B mode image. We can omit that by changing the depth setting. You can see a very nice triphasic waveform here, representing a common femoral waveform. What we can do now is we can double the peak start velocity and see what that does. Nikolai, can you do that? Nikolai's adjusting the waveform on the iPad, adjusting the sort of cartoon image to increase the peak start velocity. The profile's being sent, the machine's resetting itself. Oh, and here we have some aliasing, so we can adjust for that by increasing the scale, which increases the pulse repetition frequency. Let's bring the baseline down and adjust the gain somewhat. Yeah, that's pretty much double what we expect. Now let's see some variation in this waveform. How about we go to monophasic and drop the PSV right down. Machine's resetting itself. Here we go. Alright, let's have a better look at that by changing the scale. Yeah, that is indeed a monophasic waveform with a PSV of about 75 there. Perhaps you can increase the spectral broadening a little bit, Nikolai. Oh, very good, that's pretty dramatic. Send that. Machine's resetting itself. Wow, that's a very good waveform indeed. I think we need to make that look a little bit more realistic by reducing the sample volume. And that is a very interesting. Okay, let's have a look at the internal carotid waveform. You can adjust the peak and the end diastolic velocities. But let's see the preset waveform that's programmed in there. And Nikolai's hitting the reset button and sending that waveform. The simulator resets itself. Here we have an interesting waveform. Let's tune that up a little bit in terms of the duplex machine. Okay, that's quite internal carotid waveform. Let's see the external carotid waveform to compare. external. Send that profile. Machine's resetting itself. Yeah, and here is an external carotid waveform, more peaky, with a little notch here, dichrotic notch type picture. Okay, just one last demonstration. Can we see reflux, for instance, in a superficial vein? Let's set that up. Alright, we're going to have reflux time of perhaps, what, 3 seconds? Very good. And we'll send that waveform. The machine will reset itself briefly. That's the machine resetting. That was the augmented, the flow augmentation, that was a reflux. We'll do that once more. Let me change the baseline a bit so we can see it's resetting. Excellent. So the first part here is the calf compression, the augmented flow, and we have a reflux time there of exactly 3 seconds. And we can adjust that as much as we want. Excellent. Thank you very much.